Okay. Tamam. So today we will be talking about a completely different class of drugs, which are the antibiotics. طبعا before we talk about the antibiotics راح نحكي عن those which are synthetic antibacterial agents اللي هم السلفوناميدز الكينيلونز والترايميثوبريم. هلا بالسلايدز اللي نازله على الاي ليرنينج there is a خلينا نحكي a huge introduction about some terms you need to know or you need to understand or you should be familiar with when we talk about, let's say, antibacterials. كل هاي الانترودكشن okay, this is for you to read. It's not something that we will be or you will be asked about or that we will be discussing. Okay, الإشي الوحيد بس اللي أنا بدي أحكي عنه all right is this a slide مش included عندكم بس يعني أنا حبيت هيك just to remind you يعني even though bacterial infections يعني for now probably يعني بعضكم إنه لو أي حدا صار معاه أي bacterial infection just take an antibiotic and that's it يعني. It was a huge issue قبل الأربعينات قبل ما يكتشفوا let's say البنسلينز بالذات. البكتيريا infections were for many patients life threatening. هلا with the let's say very high incidence of emergence, it is expected that death from infections وبالذات infections by resistant strains of bacteria will exceed those of cancer. So it's a very very important issue. طبعا هاي كلها رح نحكي عن أسبابها later on. طبعا مش بالتفصيل for sure يعني أنا متأكدة أخذتوها بمساق الميكروبيولوجي. بس الpoint is إنه due to the high incidence of resistance emergence وبرضه كمان لأنه كثير في شركات أدوية صارت للأسف مش كثير تستثمر بالدiscovery of let's say antibacterials و antibiotics لأنه بالنسبة لها مش كثير profitable إنه أنا أصرف billions of dollars على development of an antibacterial within 10 years or 15 years بصير في resistance against it و it becomes ineffective. فللأسف معظم الفارماسيوتيكال companies مش focused بشغلها على development and discovery of antibacterials. معظم اللي بيشتغلوا عليه هم those are which are in the academia يعني بيعتمدوا كثير على الريزلتس أو الريسيرش اللي بيطلع من الأكاديمية على أساس إنهم to work on those antibacterials. Okay, but this is a very very important issue وطبعا كل مالها عم بتسوق يعني it is estimated للأسف إحنا ما عندناش إحصائيات بس مثلا بأمريكا تقريبا كل سنة بيموت more than 35,000 patients due to complications from bacterial infections. طيب هلا as I've mentioned اللي رح نحكي عنهم starting from this lecture and the coming lecture or two lectures اللي هم those which are synthetic antimicrobial agents أو antibacterial agents اللي هم السلفوناميدز كينيلونز ورح نحكي برضو عن الترايميثوبريم. فرح نبلش بالسلفوناميدز. Okay. هلا السلفوناميدز were discovered by a scientist called Gerhard Domack. Domack كانت نظريته إنه بما إنه البكتيريا يعني based على الجرام stains of bacteria بما إنه البكتيريا كان selectively uptake dye when stained معناها ممكن إنه هاي الدايز يكون إلها let's say antibacterial effect أو made uptake those dyes selectively and they may have antibacterial effect. فكان معظم شغله focused على الدايز إنه يصنع let's say صبغات وهاي الصبغات they were let's say testing it against the bacteria. One of those dyes that were synthesized and tested by Gerhard Domack اللي هو بسموها Prontazil rubrum. هلا البرونتازيل rubrum in vitro showed no antibacterial activity لكن in vitro it was active or did have let's say effect على البكتيريا. Do you have an explanation for that? يعني when a drug is inactive in vitro يعني بمعنى آخر على بالtest tubes أو بالagar dish if I would test this drug as it is إنه does it have antibacterial effect or not it showed no activity لكن if given to for instance mice if given even to humans it gave rise to antibacterial effect.
Prodrug?
Exactly. So the Prontosil rubrum was actually a prodrug. As it is, when binding to bacteria, or when, let's say, when bacteria is exposed to it, it had no effect. Lakin when in vivo, it will go what is known as, let's say, reduction in liver, giving rise to this intermediate that was discovered to be the active part of Prontosil rubrum. Okay? When الريدكشن صار؟ يس هاي الفانكشناليتي احنا ايش بنسميها؟ Do you know? Azo. Now this azo group, or when you have a double bond between two nitrogens, is a reducible bond. Many enzymes can easily, if they bind to this drug, they can easily, let's say, hydrogenate this bond, eventually breaking it, and thus breaking the molecule into two parts. The two parts, or the two resulting metabolites, when tested, they found out, it's this one that is called sulfanilamide is the one that is active against the bacteria. Okay? طيب. What are the functionalities in this drug? What is this functionality? Yeah. When we say sulfur, sulfur refers to an atom. Okay. هلا ال SO2 and H2 it refers to this functionality. لو أنا بدي أرسمها صح. Okay. هاي إحنا بنسميها sulfonamide. Okay. But what about this one? When you have a nitrogen that is connected to an aromatic ring or benzene ring, aniline. Okay. Thus, let's say, sulfanilamide states that we have an allynyl group and a sulfonamide group in this compound. طيب. Does anyone have any, let's say, remembrance? What does sulfanilamide do? Or what is its mechanism of action before طبعا we will go deep into it. But in case مر عليكم بالpharmacology, do you remember? Yes, it eventually inhibits الfolate synthesis in bacteria. هلا تذكروا انه when we talked about الانتينيوبلاستكس ذكرنا عن الfolate synthesis او الفوليت. لا. طيب what are folates important for؟ تتذكروا؟ For the synthesis of, and الfolate when uptaken from diet, okay, we cannot, you already know that we cannot synthesize folic acid. This is the structure, let's say, of folate or polyglutamate folate or folic acid. الفاريشن ما بين folic acid و folate إنه بس ionization form of the carboxylic acid in its structure. هلا الفوليك acid أو الfolate is a precursor for the synthesis eventually of tetrahydrofolate. And if you recall لما حكينا عن 5-fluorouracil أو sorry بالdihydrofolate reductase حكينا إنه THF is very important as a cofactor that is used to synthesize a thiamine from uracil, which is eventually important for DNA synthesis. بمعنى if you would inhibit الfolate synthesis أو الfolic acid synthesis أو eventually synthesis of dihydrofolic acid, you will be indirectly inhibiting the DNA synthesis وبالتالي for bacteria ما راح يصير في عندي multiplication أو growth. Okay? هلا do we synthesize الfolic acid؟ لا, we get it from diet, but bacteria, okay, cannot uptake folic acid from the media. طبعا except for some few resistant strains only. لكن bacteria in general cannot uptake or cannot consume folic acid coming from diet. It needs to synthesize it in يعني inside their cells. All right? How this happens? طبعا مش ضروري انكم تعرفوا exactly this entire route for tetrahydrofolic acid or THF synthesis. That is in bacteria also used as a cofactor for eventually synthesis the precursors needed for DNA synthesis, which is very important for bacterial growth. احنا رح نحكي عنها ونركز عليها so that we understand eventually السلفوناميد structure اللي بيشبهوا مين and why they inhibit that particular enzyme. Okay? So the exact steps, the exact structures of the precursors in here are not, or you do not have to memorize them exactly. You just need to know, generally speaking, in a THF or dihydrofolate followed by then THF in bacteria are synthesized from this precursor, which is called, let's say, pyridine pyro or dihydropyridine pyrophosphate. Okay, pyrophosphate because we have two phosphatic groups that are attached to this oxygen. هلا اللي بتعمله البكتيريا it uses this precursor, then it reacts with this compound that is called para-aminobenzoic acid because I have a carboxylic acid attached to a benzene and an amino group that is para to this carboxylic acid, thus the name para-aminobenzoic acid. The enzyme responsible for this process is called dihydropteroate synthetase or synthase. This enzyme binds to both the para-aminobenzoic acid أو اللي احنا أحيانا بنختصره PAPA, okay, with this precursor and synthesizes this one. How? كيف برأيكم بصير عندي السynthesis of the dihydropteroate? طيب. Is this and you look at the bonds, look at, let's say, those two parts والبonds اللي تكونت. So here I have a bond ما بين this nitrogen in para-aminobenzoic acid and this carbon in here. Which atom acts as a nucleophile? In nitrogen, that's the nucleophile. And where is the electrophile? This carbon, okay? Why is it electrophilic? بمعنى إنه الإلكترونز مسحوبين منها. Because I have an oxygen, not only oxygens, also phosphates group that are attached to that oxygen withdrawing electrons inductively, leaving this carbon with a partial positive charge. That is why it's electrophilic. Okay? اللي بيصير ببساطة إنه الإنزيم when it binds to both substrates بيقربهم من بعض بيوفر ال perfect environment for them to interact with each other. And nitrogen now can attack this carbon وبتكسر الباند ما بين الكربون والأكسجين. تطلع الأكسجين مع الفوسفاتس أو بتطلع two phosphates let's say out. The two phosphates are, or phosphates in general are very good leaving a group. Okay? And this is how this bond is formed ما بينهم. Between the para-aminobenzoic acid والdihydropterine pyrophosphate. Then later, a glutamic acid is linked to it, and this is how dihydrofolate synthesized followed by tetrahydrofolate. Okay? طيب السلفوناميدز خليني افرجيكم او ارسم الستركتشر اوف سلفونيلاميد. structure اللي بيشبه مين؟ looks like what? Which part of this pathway it looks like? بيشبه مين؟ The structure of sulfanilamide acid, which is one of the sulfonamides, looks like what? Yes, the PAPA or para-aminobenzoic acid. They are almost exactly the same, except in the carboxylic acid is substituted with a sulfonamide. يعني in other words, this enzyme would mistakenly bind to sulfanilamide or sulfonamides thinking that it's para-aminobenzoic acid. Okay, so is it a competitive inhibitor, a sulfanilamide, or a non-competitive inhibitor? Competitive inhibitor because it competes with para-aminobenzoic acid when binding to a dihydropteroate synthetase. That's the target enzyme that it inhibits. Okay. This is an extra image بدي أفرجيكم إياها وهيك ندخل شوي بتفاصيل الميكانيزم بس يعني هاي الديتيلز كلياتها مش مطلوبة منكم. This is the structure of dihydropteroate synthetase. خليني أختصره DPS. This enzyme, okay, if we zoom in على where the active site is, okay, which is shown in this image, you can see the para-aminobenzoic acid, which is this part in here. This is the benzene, the carboxylic acid, and the amino group. And that part in here is dihydropteroate pyrophosphate. Tamam? So as you can see, the enzyme, when binds to them, it gets them very, very close to each other. It positions the nitrogen group that is part of para-aminobenzoic acid very close to this electrophilic carbon of dihydropterine pyrophosphate. لاحظوا انه النيتروجين هلا can easily attack this carbon وبتطلع عندي two phosphates groups, and this is how the bond ما بين para-aminobenzoic acid with DHPPP forms, giving rise to this precursor واللي later إذا انربط عليه الجلوتاميك أسيد بيعطيني الدihydrofolate. Okay, so it's a simple nucleophilic electrophilic reaction والإنزيم بيشتغل وكأنه reaction vessel of this binding أو this synthesis. طيب هلا something you need to know إنه even though الإنزيم أو السلفونيلاميد أو السلفونamides in general may bind to the enzyme or compete with para-aminobenzoic acid, الإنزيم بما إنه still أنا عندي النيتروجين موجودة في السلفونيلاميد. Okay, يعني here if the enzyme would bind to the sulfonylamide or any other sulfonamide, that reactive nitrogen is still there. فاللي بيصير انه احيانا انه ممكن هاي النيتروجين تتفاعل with dihydropterine pyrophosphate, okay, ويصير في عندي bond بين السلفونيلاميد او السلفوناميد in general and dihydropterine pyrophosphate. Okay, لكن this one is considered a false metabolite, will not be effective eventually أو ممكن إنه ما يرتبط مثلا ب let's say thiamidylate synthetase which is responsible for the synthesis of thiamine. فسواء ارتبطوا ما صار في reaction بين السلفونيلاميد أو السلفوناميد والدihydropterine pyrophosphate أو صار ما بينهم reaction وتكون عندي product, the product itself is considered a false metabolite, ما راح يكمل ويعطيني eventually a carbon source needed for DNA synthesis. Okay. طيب لا if you look at the structure of para-aminobenzoic acid لما يرتبط بالإنزيم أكيد راح يصير في بينه وبين الأمينو أسيدز اللي موجودة في البايندينج أو في الأكتيف سايت interactions. Okay, otherwise إذا ما صار في بينهم let's say non-covalent interactions أو interactions in general ما أصلاً راح يرتبط هالسبستريت بالإنزيم. فهلا looking at the structure of para-aminobenzoic acid شو بتتوقعوا الانتراكشنز اللي ممكن يعملها؟ Imagine that this is the binding site or this is the pocket where this part of the para-aminobenzoic acid binds in. Can you guess what kind of interaction ممكن إنه هالكمباوند يعملها؟ Hydrogen bond بين مين ومين؟ Yes. This amino group in here can form hydrogen bond interaction إذا كان في حواليها amino acid that is considered able to form hydrogen bond interaction. طيب is this nitrogen ionizable؟ اللي موجودين online كمان سامعينكم يعني feel free to answer.
Not
Is it?
No.
It's not ionizable. Okay, it's not. Why is that? Yes, because the lone pair of electrons being directly connected to a benzene ring, for sure راح يصير في عندي electron withdrawal via resonance. Okay? Not only with this benzene, حتى كمان مع هاي الكربوكسيليك acid يعني ممكن الريزونانس يوصل لهاي الكربونيل of the carboxylic acid. So there is high electron withdrawal inductively and via also resonance. فالإلكترون density عليها low, ال pKa لها راح تكون low, will not be ionizable at physiological pH. طيب, what else? What do you think this benzene can form?
Ionic interaction.
لا, البنزين.
الكربوكسيليك acid.
pi stacking or van der Waals interactions. Okay. طب what about the carboxylic acid? Something stronger. الكربوكسيليك acid ايش البي كي اي لها؟ Almost 4, yeah, around 4.6. This one in particular 4.6. Okay. Yeah. هلا ليش higher than 4؟ لأنه أنا في عندي nitrogen donating electrons to it. طيب 4.6 معناها at physiological pH will be mostly ionized or in the form of a carboxylate. Yes, it can form إذا كان in where it binds amino acids that are also ionizable ممكن يتكون عندي ion-ion interaction أو an ionic bond. Or if, let's say, the amino acids around it can form hydrogen bond interaction ممكن يتكون عندي an ion dipole interaction, which is also a very strong interaction. Okay? طيب, let's look now at one of the derivatives of sulfonamides, this one in here. Does it form the same interactions or similar ones? Yes, في resemblance عالي بالstructure ما بيناتهم. This amine can also يعني size wise it fits perfectly بالbinding pocket اللي يفترض البير امينو بنزويك اسيد يرتبط فيها. الامينو acids اللي موجوده حواليها that amine can form hydrogen bond interaction. This one can form van der Waals interactions or what we call a pi-pi stacking. And what about this group? طبعا رح نحكي هلا عنها بالتفصيل الممل. بس what do you think this group will form? وين الأسيدك part فيها? For sure, the proton in here. Okay? Yes, that proton is the acidic part. Can be lost easily. Okay, ال pKa لإله تقريبا for this one in particular تقريبا 5. هلا مش كل السلفوناميدز ال pKa لهم مقاربة to that of carboxylic acid. رح نحكي عنهم بالتفصيل. The first one that that was discovered اللي هو السلفونيلاميد وايش بعدين اللي هي الفاريشنز اللي انعملت بالستركتشر حتى اوصل ل pKa مقاربة خلينا نحكي ل that of a para-aminobenzoic acid. But also this compound can form very similar interactions with the binding site or the active site of dihydropteroate synthase or synthetase. Okay? هلا يعني بما انه we have a good amount of time بدي افرجيكم هالسلايد. And I want you to look to those different derivatives of sulfonamides. Okay? واحكوا لي based على مين active ومين inactive ايش ال structure activity relationship map اللي ممكن تطلعوا فيها. Yep. So those two substituents, the sulfonamides will amine, they should be para to each other. Okay. As she has mentioned, probably what is forming hydrogen bond interaction with the amine and the sulfonamide are para to each other. Okay. بpositions معينة relative to each other. فبالتالي إذا أنا بغير الأمين معناها ممكن this one fit in its pocket, but this one will be far away to form any kind of hydrogen bond interaction. They need to be para to each other. What else? Yeah, if you would, let's say, or if that sulfonamide would be tertiary, بمعنى إنه عليه 3 أو يعني 2 substituents besides the sulfonic group, in that matter, it will become inactive. So I need to have at least a hydrogen, أو in some cases يعني this is a derivative مش رح نحكي عنه لازم تكون group إنها ممكن تنشال in vivo. Okay, but for خلينا نحكي our course أو for the exam questions, memorize or understand that we need to have at least a hydrogen on this nitrogen or on the sulfonamide nitrogen. What else? Yes, so it's an essential group. If you remove it, the compound will become inactive. لأنه simply it will lose that hydrogen bond interaction that is anchoring the drug to the active site. Yes, if it is methylated, for instance, okay, it will become inactive. ممكن هاي بسبب إنه بتقل عندي number of hydrogen bond interactions اللي ممكن يعملها, or إنه that extra methyl group may clash, أو ممكن ال binding site اللي محل ما بترتبط ال NH2 is very small, cannot fit let's say the extra methyl اللي أنا ممكن أضيفها على النيتروجين. So those two are two plausible explanations. What else? عفوا. Yes, so we need to have also the aromatic ring as it is. If you would saturate that benzene ring, or in particular entirely, you will lose the activity. Do you have an explanation for that? Yeah, it will definitely become ionizable. بس برأيكم why if you would replace البنزين with هاي الرنج احنا ايش بنسميها؟ Yeah, it is a hydrocarbon chain أو cycle. The particular name for it cyclohexane. إذا بدلت البنزين with cyclohexane ايش الأكتيفيتي عندي will be diminished.
No van der Waals reaction.
What? معلش بس تعيدي أغلبك.
ما في باي stacking.
ما في باي stacking. Still يعني الكاربونز اللي موجودة ممكن تعمل van der Waals interaction. طيب, what is the hybridization of all those atoms? What is the geometry around each of those carbons? Planar. طب what about those carbons in here? Exactly. هلا احنا صح هون مرسومة وكأنها planar, لكن the 3D representation for it إنه the most stable conformation of cyclohexanes is what? Chair. Okay? يعني على سبيل المثال لو عندي هاي substituents على بنزين, they will be الزاوية ما بيناتهم إيش؟ 180, and they will be planar. Those two groups will be planar to each other. On the same plane, the distance between them, or the angle between those two groups is 180. But for instance, لو أنا غيرتها لcyclohexane ولو افترضنا إنه this is the sulfonamide group, okay, and this is for instance كانت عندي ال NH2 group, يعني ممكن تكون equatorial, ممكن تكون axial. Now the distance between them would be slightly different. The angle between them would be slightly different, which means إنه they will be positioned in pockets ممكن ما يكونوا fit for them anymore, وممكن يبعدهم عن الامينو acids اللي ممكن تعمل interactions معاهم. Okay, that's one explanation why if you would substitute the benzene with cyclohexane, you will lose the activity. مش بس إنه أغيرها تماماً أو to completely saturate it. Any dehyde أو any hydrogenation, يعني يصير في عندي let's say 2 double bonds instead of 3 and so on, for sure الأكتيفيتي راح تقل بشكل كبير كمان. Okay. طيب, what else? يعني تقريبا أنا لازم أحافظ على ال NH2 وأحافظ على البنزين وتكون ال NH2 para to the sulfonamide. Most of the change اللي شايفينه بالactive analogues وين بصير عندي أو وين هو معمول؟ Mostly. Most of the change in the structure of sulfonamides. Yeah, the substituent, let's say, or those substituents on the sulfonamide nitrogen. طيب, لو أنا بدي أصنفهم أو for instance structurally, if I would generalize طبيعة هاي الجروب اللي مرتبطة بالسلفوناميد نيتروجين, شو بحكي عنهم؟ In most of the analogues you see in here, مرتبطين ب
electron withdrawing group.
Exactly, electron withdrawing group. يا إما for instance إذا كانوا aromatic rings بيكون في عندي فيهم hetero atoms that are withdrawing electrons as you can see, أو in case كان في مثلا عندي one example اللي هو لما يكون في عندي a carbonyl. Okay, and we will explain why for sure. So let me go back to this slide and summarize everything that we have talked about. Again, those nitrogen or the amino group and benzene are essential for activity. Okay, you need to keep them. The nitrogen must be, let's say, para relative to the sulfonamide group. Generally speaking, I need to leave the amino group let's say not substituted. الحالة الوحيدة اللي ممكن يعني أضيف عليها substituent اللي هي in the case of adding an acyl group. And when we talk about prodrugs راح نحكي we will talk about them and the purpose of adding acyl groups عليهم. Okay. هلا why if you would add an acyl group الكompound بيكون عندي still active لكن only active in vivo. In vitro it's inactive. يعني in other words لازم هاي الacyl group for the compound to bind to the target اللي هو dihydropteroate synthetase. This group needs to be hydrolyzed. Okay. البنزين ring should be a benzene ring. Okay. Any kind of saturation يعني hydrogenation سواء كان single di or triple أو sorry complete hydrogenation we will lose the activity. And as for the sulfonamide group, I need to have at least one hydrogen على النيتروجين. Will R groups in general, as we will see later, electron withdrawing groups, or mostly بيأثروا على potency, يعني how strong the drug is binding to its target, the pKa, pharmacokinetic properties of the drugs, and so on. أو of the sulfonamides. Okay, راح نحكي عنهم هلا بالتفصيل. Yes. I cannot let's say be sure لأنه أنا ما شفت بالليترشر يعني أي حدا غير هاي البنزين مثلا with a pyridine. يعني ممكن يعني وارد إنه ممكن لو غيرت البنزين with a pyridine ممكن إنها تكون active بس I have يعني to be sure 100% about that يا إما إنه في حدا بده لازم يفترض يعمل docking in silico يعني ناخذ الكريستال structure this is يعني this requires computational modeling. نعمل docking بالكompound نشوف إذا still في good interactions ولا لا أو إنه حدا يكون already صنع such an analog and tested it in let's say in vitro. بس those are the only two خلينا نحكي ways اللي أنا ممكن أحكم 100% إنه if you would substitute it with a pyridine still active أو still will be active or not. بس لأنه ما حدا أو يعني I haven't seen in literature such information فمش هسألكم عنها يعني. This is something we cannot predict يعني for this course. هلا حكينا إنه الكربوكسيليك acid is an acidic group with a pK of around 4.9. طيب السلفوناميد group بالسلفونيلاميد. Do you remember what is its pKa value؟ هاي شيء أخذتوه بميديسينال 2 على فكرة. 1 أوكي. هلا 5 لما يكون عندي let's say an isoxazole مرتبطة فيها لكن بالسلفونيلاميد لحاله لما ما تكون في electron withdrawing group. طيب تتوقعوا إنها أعلى من 5 ولا أقل؟ أعلى بمعنى إنها less acidic ولا more acidic؟ less acidic. Okay. طب yes. Why do you think it would be less acidic؟ هلا في
توري 10.
Yes. The actual value of the sulfonamides group is around 10. Okay. Why is it higher than a carboxylic acid? لأنه if you would look at the conjugate base, if you would lose one of those protons, that negative charge developed on the nitrogen, oh, it's on a nitrogen. Mean more electronegative, النيتروجين ولا الأكسجين؟ الأكسجين. بالتالي مين بتحمل إنه يكون عليه النيجاتيف تشارج بشكل أفضل؟ الأكسجين. فذات is why such a conjugate base ما بيكون عندي very stable relative to that of a carboxylic acid. That is why the pKa is higher. طب لما أحكي 10 versus 5 معناها how much السلفونيلاميد are less acidic than الكربوكسيليك أسيد 5 مرات أقل. It's 10 to the power of 5. This is what pKa values mean. It's 10 to the power of 5. يعني البنزويك أسيد أو الكربوكسيليك acids are almost 100,000 times more acidic than السلفونيلاميد. طيب هلا again, why or how can we enhance the acidity or increase the acidity structurally speaking? Yes, إنه أضيف أنا على السلفوناميد group or substitute one of the protons with a group that is considered electron withdrawing a group, okay? Such as, for instance, as you can see in here, if you would substitute one of the hydrogens with this ring, which is a, do you know the name of this ring? بما إنه فيها sulfur, which is thia. Yes, it's a thiazole ring. And what about this ring?
Pyrimidine.
Yeah. Yes. Or, generally speaking, diazine. تمام؟ هلا ليش البي كي اي صارت 10؟ لا 5 for isoxazole. لما يكون عندي let's say يعني for the sulfonamide group in sulfanilamide where you have 2 protons or 2 hydrogens, it's 10.4. But if you substitute one of the hydrogens with an electron withdrawing group اللي هي الايزوكسازول, البي كي اي عندي راح تصير اقل. We will see that let's say analog بالسلايد اللي بعده. اوكي لكن generally speaking السلفوناميد جروب بالسلفونيلاميد البي كي اي لها 10. If you would attach electron withdrawing groups such as those 2 aromatic rings in here, they will withdraw electrons inductively ولا via resonance. شو رأيكم؟ ولا via both? Yes. Okay. So this nitrogen or those 2 nitrogens in here will withdraw electrons inductively. يعني بيسحبوا electrons through sigma bonds, and also the lone pair of electrons in here can resonate with the aromatic ring. Same thing for this one in here. Okay? So that is why such a group بما إنهم electron withdrawing a group معناها they will weaken the bond ما بين النيتروجين والهيدروجين والconjugate base form will be more stable. فالبي كي اي شو بصير لها؟ بتزيد ولا بتقل؟ بتقل. Alright? البي كي اي will become less. For السلفاثيازول تقريبا هي 7 point يعني 8 something like that. It's definitely less than 10. Okay? For السلفا diazine 6.48 almost the pKa. معناها at physiological pH more than 50% of the molecule تقريبا 86% will be ionized. طيب ما بين السلفاثيازول والسلفا diazine مين more acidic برأيكم؟ طيب السلفر in terms of electron والكترونيجاتيفيتي أعلى ولا أقل من النيتروجين؟ أقل. ليش أقل؟ Yes, because it's a third row atom. بمعنى إنه الإلكترونز اللي بتكون موجودة على الأوتر شيل أبعد عن النيوكليوس versus النيتروجين. فبالتالي قدرتها إنها تسحب إلكترونز راح تكون عندي أقل. Okay? Here I have 2, let's say nitrogens. Here I have a nitrogen and a less electronegative atom اللي هي السلفر. Okay? طيب what about the resonance? مين برأيكم بيكون السحب أكثر؟ يعني لو سألتكم مثلا إنه بدنا نرسم أو ترسموا resonance structures for the electron withdrawal of electrons or for the electron withdrawal from this sulfonamide nitrogen. هلا أنا ممكن أحرك الإلكترونز like this where they will reside on the nitrogen. هلا لو فكرت إني أنا أكمل يعني let's say draw it عشان hopefully إنه تكون الصورة أوضح. This is one resonance structure that I can draw, and that's another. Can I move the electrons to form such a bond in here? لا. Okay, لأنه السلفر بيكون في عليها let's say two orbitals having two electrons already filled. يعني السلفر cannot accommodate any extra electrons. Okay, يعني already electrons أو آسف orbitals اللي فيها filled both have two pairs of electrons. تمام? So those are the only two resonance structures that I can draw for the thiazole group. طيب what about الديازين؟ خلينا نجرب نشوف. And based on that then we can judge. I can move the electrons بحيث إنها يكون في عندي negative charge in here. How many resonance structures I have drawn? 3, okay? And in 2 of those resonance structures, I have negative charges على النيتروجين، واللي كثير أفضل إنهم يستقبلوا أو يكون عليهم النيجاتيف charge versus إنها تكون عندي على carbon. Here I have 2 resonance structures where only in one of them I have the negative charge on a heteroatom. In the other form, there is the negative charge is on a carbon. So that is why this group, its electron withdrawal effect is way or much better than that of sulfathiazole. فعشان هيك البي كي اي لها بتكون عندي أقل. السلفاثيازول تقريبا 8 something like that. Okay. طيب. They even went further إنه خلينا نضيف إحنا groups تكون even more in terms of the electron withdrawal. And this is what they've done, or this is why they synthesized this derivative اللي هو sulfa isoxazole أو sulfa-isoxazole. This group that you see in here is called isoxazole. Okay? هلا الالكترون withdrawal effect لإلها أفضل. ليش؟ There is a highly electronegative atom اللي هي الأكسجين اللي بتسحب الإلكترونز منها وبتسحب الإلكترونز من النيتروجين بشكل كثير أفضل. ال pKa for this one versus the sulfadiazine تقريبا around 5, which is equivalent to that of the carboxylic acid بالpara-aminobenzoic acid. لسه أحسن. Yes, الsulfa-isoxazole. لكن المشكلة إنه طبعاً because of that we can generate salts out of this compound. لما تكون عندي ال pKa similar to that of a carboxylic acid, I can formulate the drug in the form of a salt. Okay. هلا المشكلة هون إنه what they found out إنه الأفضل experimentally أو الأفضل let's say clinically إنه تكون عندي range ال pKa of the sulfonamides ما بين 6.6 and 7.4. أوكي؟ صح الwater solubility كل ما أنا قلت عندي ال pKa بتكون عندي أفضل، لكن at the same time لما أزيد أنا solubility أو water solubility بشكل relatively speaking عالي بصير عندي ال penetration through the cell membrane أصعب. فالdistribution بيكون عندي أسوأ for those drugs to pass the cell membranes or even cell walls for البكتيريا. Okay? Clinically, the optimal range for the pKa of sulfonamides يكون ما بين 6.6 and 7.4. مش معناه إنه الsulfa-isoxazole is not effective, all right? لكن in terms of the let's say الeffectiveness أو خلينا نحكي distribution in bacterial cells اللي بيكون لهم ال pKa أعلى من 5 relatively speaking أفضل. Okay. طيب. One of the issues that was seen بالsulfonamides بالذات ال first generations اللي هم الsulfonamides اللي بتكون لهم ال pKa ممكن 8 and higher than 8 و in particular بالsulfanilamide اللي هي الكريستاليوريا. Okay. الكompounds أو those compounds في acidic values for the environment بالurine they will become أو نسبة ionization even بتقل أكثر وأكثر because these are acidic compounds which would increase the chances for those drugs إنه يصير لهم precipitation أو crystallization في الurine. فusually to overcome that issue بال very early sulfonamides كانوا دائما ينصحوا patients إنهم ياخذوا كميات كبيرة من المي with when taking let's say that medication أو أحيانا إنهم يشربوا let's say الcarbonates على أساس إنهم to increase the pH of the urine حتى إنه يقللوا من chances for the crystallization of sulfonamides. طيب. The main metabolism اللي بيصير عندي على الsulfonamides اللي هي as you can see in here acetylation. أنا بصير في عندي acetylation على this nitrogen which would lower or increase the water solubility برأيكم. Yes, because such a group will make the compound even less polar or more lipophilic, which would increase, let's say, even the chances for precipitation or crystallization for it. Okay? هلا later on راح نشوف إنه أحياناً the administered drug would be in the form of an acetyl حتى إنه أنا أزيد من absorption of that drug. يعني it's an خلينا نحكي it's a reversible process. الميتابولايزنج enzyme ممكن تضيف an acyl group على الكompound وبرضه كمان الاcyl group if present in a compound it may undergo hydrolysis. طيب. هلا you probably يعني something you have encountered أو حكيتوا عنه definitely بالفارماكولوجي إنه الsulfonamides يعني relatively speaking was almost replaced by الpenicillins أو البيتا-lactams in general. يعني these are rarely used due, let's say, to their relatively speaking low spectrum of or narrow spectrum of activity, a high emergence of resistance against them, and so on. Okay. راح نحكي فقط عن أو راح نشوف فقط few of them وراح نحكي عن some of their uses. وإن particular راح أركز على السلفاديازين والسلفاسيتاميد. Okay. السلفاديازين is mostly used for treatment of burns. يعني just in case إنه في حالة البرنز ممكن يتعرض البيشنت إنه يصير ممكن يصير infections. السلفاديازين is used let's say to prevent or even treat an infection if it happens. هلا الantibacterial activity is not only because of the sulfonamide compound وإنما also because of the sulfur itself. The sulfur ions themselves they also have antibacterial effects. يعني الion والcounter ion اللي هو silver ions both of them they have antibacterial activity. That is why it's very effective for, let's say, prevention or treatment of infections associated with burns. طيب, السلفاسيتاميد is used for ophthalmic preparations. هلا كلكم بتعرفوا إنه for ophthalmic preparations الدرج يفترض يكون highly water soluble. يعني if for instance if I need to prepare this in the form of a solution لازم تكون له solubility عالية جدا. طبعا definitely it is prepared in the form of a salt. طيب هلا لو أنا مثلا بدي أسألكم السلفاسيتاميد in terms of its pKa تتوقعوا رح تكون أعلى مثلا من السلفاديازين السلفايزوكسازول ولا أقل؟ شو رأيكم؟ Would you expect the pKa for sulfasitamide to be higher or lower than مثلا for than السلفاديازين؟ أعلى، ليش أعلى؟ طيب مين بحكي أقل ال pKa؟ لا بالعكس. هي مش إنه أعلى ال pKa أقل، الأسيديتي أعلى. لأنه that carbonyl, okay, having this oxygen very close to the nitrogen, it is withdrawing electrons inductively and also via resonance. يعني I can, let's say, draw this resonance form. Oxygen is way much better than nitrogen in having higher electron density لأنها more electron negative. It's a more electron negative atom. It will highly withdraw electrons inductively and via resonance from that nitrogen. That is why its pKa راح تكون عندي, let's say, أقل from that of sulfadiazine. فبالتالي لو بدي أنا أحضر salt منها in a form of a solution أو to be when dissolved in water ما راح يصير له precipitation. السلفاديازين مثلا السلفا أو السلفاثيازول for instance إذا بدي أحضر salts منهم أوكي وأذوبهم في مي ممكن يصير لهم precipitation لأنه برجع بصير في equilibrium لأنهم مش كثير highly acidic بصير في an equilibrium they will uptake a proton from water بيتحولوا into the neutral form that will precipitate. That is why sulfacetamide is the one that is suitable for treatment of or as an ophthalmic antibacterial agent. لا العكس هلا for acids okay the more the pKa value the lower the acidity والrelation عكس بالbases okay basic أكثر طبعا if we are talking about let's say a basic group بس لما نحكي عن acidic functionality كل ما عليت ال pKa الacidity عندي بتقل okay 4 أقل أقل بشوي مش كثير أقل بشوي yes هلا السلفادوكسين طبعا يعني when they discovered the sulfanilamide and they've started changing the groups اللي موجودة عندي على النيتروجين they came up with a lot of let's say derivatives اللي هم الايزوكسازول ميثوكسازول diazine thiazole acetamide and so on okay later especially with the emergence of resistance they went back into developing different derivatives also of sulfonamides which gave rise to sulfadoxine. هلا بيميز السلفادوكسين relative to the other sulfonamides اللي حكينا عنهم so far إنه it is highly protein bound this compound and because of that the half-life for it is very high and this antibacterial agent can be given once a week because of its very high protein binding. خليني أوقف هون والمحاضرة الجاية إن شاء الله بنحكي عن البرودراجز of sulfonamides وبنحكي عن الترايميثوبرام which is very closely related للsulfonamides وبنكمل عن الكينيلونز. تمام؟ يعطيكم ألف عافية يا جماعة. اللي موجودين أونلاين في أي حدا عنده أي سؤال؟ الله يعافيكم.